Welcome to Vectorworks 2B Lesson 2A. In this lesson we're going to discuss advanced 2D techniques and a brief introduction to 3D. I'm your guest lecturer, James Russell. So welcome back everybody. Today we're going to run through some of the commands that you'll find up in your menu bar here that will be helpful to you, and also we're going to go through adding, subtracting and intersecting basic 2D shapes. So to begin with today we're going to talk about the move command. I've got two little examples set up here. The first one's quite basic and we'll have a look at it now. This is a little lectern that I've built to put on this piece of staging here. It's a 2x1 piece of rostra. This is my lectern. Now what I want to do is position this slightly offset from the center and down, and what I'm going to use is the move command. Previously we've talked about moving things by the X and Y, which is fine. You can see here, because this is a group, it's actually got the plus and minus for me, or for you guys it'll be this triangle representing a change in size. So you can see if I put in plus 100 here, it will make my lectern slightly wider. And here in the X value you can see I'm negative 640, which means in this case the center of this lectern is sitting around 640 somewhere here. And I could put in numbers here, I could add 100 to that and that would move that across. But that isn't quite helpful for the move command, so we're going to do this instead. I want this to sit from the center, I want it to sit 200 mil down towards the center of this staging section, and I want it to be 300 mil to the left. So what I'm going to do is knock all of those over in one go by using our move command up here. So I'm going to go down from the modify menu and go to move, and you can see it pops this menu over here, move and move 3D. They are also accessed for me by Control M, or for you guys by Apple M. When you click this it brings up a small little box here. It might be slightly different for you guys on the Mac, but there's two options here, the Cartesian plane and the polar plane. For those of you who have done your Year 9 and Year 10 maths, etc. will know about the Cartesian plane as our X and Y axes. And just to kick that right off, I said before that I'd like this to be 200 mil down, so that's in the Y. I'm going to put negative 200. My 2 key is mucking up at the moment. And in the X I want it to move to the left here over 300, so that's a negative movement in the X. Just to quickly explain polar is a different coordinate system. As opposed to moving things up and down and left and right, it uses an angle from the north point here, so maybe 45 degrees out this way, and then a distance to move it. It can be useful, but it's a little bit tricky to master. So clicking OK, and you can see it's moved 200 mil down from its previous location, and I can just show you that it is actually 200 down there, a length of 200. And it's also moved 300 mils off center, so if I just line that up there you can see it's 300 mil. Now the other example, which you might have seen in the solution video if you've watched it by now, is how I arranged all of these little pieces together. And simply what I was doing is arranging these to convenient points, and then knowing my spacing distance, I was using the move command. I've just pressed Control M, or for you guys Apple M, and then knowing the offset that I wanted, which in this case will be 50 mil, and typing that in and pressing enter. So just to show you that again, I was finding the location that I wanted to line these up to, opening my move command. It's remembered my previous things from last time, but I wanted this one in this case to move 50 mil to my right. That's a positive change in X. Click OK and you can see it's moved that 50 mil out for me. Similarly with these ones here, and I'll just line this up to here, I now need this to move down, and because this is the easiest snap point for me to get to, is one of the corners or one of the center pieces or something like that. So I'm going to press my Control M again, and this time change that so that there's no movement in the X and a negative movement in the Y by typing in minus 50. Clicking OK, you can see it's put that nice little border in there. And similarly with this one, if I can get it locked into there, which I know it must line up to in the center there, so that's the spacing on either side taken care of. And just remembering my previous settings, bringing that up, clicking OK, and there it is. So a really easy way just to get the spacing down without me having to think about moving these. Obviously I could have typed in a movement here in X or Y if I felt like it. So that's the move command taken care of. It's pretty straightforward. Move 3D is quite similar, and we will talk about it a little bit, but it just adds the third component there of movement, X, Y and the Z axes. So shuffling along my page here, we're going to look at the rotate command. We've obviously discussed the plane rotate command, but here's a few shapes that I've got going on. Obviously this one here, I need to rotate it. This is a square. To fit into this hole, it needs to turn 45 degrees. the three ways of doing that. I could grab it first here, use my rotate command, draw an extension line out from here and rotate to 45 degrees. The second way I could do it is I could go over here to the rotation of the rectangle, type in 45 degrees and press enter. Or the third way is to use the menu here by clicking on the item, going up to our modify menu again, scrolling down to rotate and choosing the rotate command here. And this is exactly the same as this little panel over here, just lets us rotate from its current position. So I'm going to type in 45 degrees here, press enter, and there's my rotation. You'll see that that will fit straight into there. Now what's good about this is here I've got a polygon, and once again I can use this rotate command here again to rotate that round into where it needs to fit. But you can see that because this is a polygon, and same with this similar next one, it doesn't actually have the rotate origin command here because Vectorworks doesn't know where this originally started. It knows where the rectangle started off because that's a basic component. But these more advanced ones, it has no idea which way their upwards or nominal value is. So instead I'm going to use the modify command here. I'm going to choose rotate again. And this time I'm going to rotate 30 degrees round. Just so you know, this is a 6-sided object, so 6 into 360 is 60 degrees. So I want to rotate that half a single turn of 60 degrees, which makes it 30, and you'll see it's done that now for us. And this last one here, now this is probably the trickiest one, and unfortunately there's only one way to fit this into the rotation, and it's not by the rotate menu up here, unless you know what the previous rotation was. So the only way that I feasibly can do this is by choosing a point. Now I'm looking at this and I know there's a couple of points that match up. Going for this pointy part here, and I'm going to pop it in its counterpart corner down here. From there I'm going to grab the rotate command from this menu here, and I'm going to have to click on this, so pin the point first. Secondly, I'm going to choose a familiar point. Now this doesn't quite work if I just choose a random point out here. I'm still going to end up with the same thing. I could obviously do it by eye, but it wouldn't be quite accurate. So instead, I'm just zooming in here, I'm going to click on this part here, which I know will eventually match up to here. So I'm going to click here. You can see as I rotate it up, I can snap into here, click again, and there's the shape fitting in quite nicely. So that's the rotate command taken care of. There isn't a shortcut key, by the way, for the rotate command, but you can set one if you'd like to. So moving along here, we've got align and distribute command. And I did discuss this in the solution video if you have a watch of that, if you haven't watched it yet. This is another quick description for you. So I'm just going to briefly run over. I've got some circles here, and firstly I'd like them all to be evenly spaced apart. So from the modify menu, I'm going to choose align and align distribute. Clicking on this brings up this interface here, and it's really nice to use. So it just works across the page and up and down the page. So I want to work across the page, I want them to be distributed, and then there's several options: by their left hand side, by their centers, by their right hand side, and by their spacing. And center and spacing are the confusing ones here, and we'll talk about those in a sec when I do some odd shapes. But I'm just going to do by centers, and you can see it's lined all of these objects up by centers. Click OK, and you can see it's spaced them nicely along here. Now the other thing that I wanted to do was to have them all end up on this line here. So there's two ways of doing that. I could go here, align distribute. I don't want to distribute them by centers anymore, although it wouldn't have affected them. I actually want them to align, and I'll just align them to centers. So it's chosen the center of that giant group and aligned all of those to there, and then I can drag them down to here. The other option would have been that I could have dragged the lowest or the top of the group, maybe I'll do the top, onto that line there, and then just changed my align distribute settings so that it was aligning to the top object of that collective pack, which is this one here. Click OK, and there they go. Two just similar ways, both take the same amount of time, it's just which way you want to do the order really. Now the second lot of stuff here, I've got some random objects that have been thrown into the group. And I want a similar thing, them all to end up on the same line, but I also want them to be evenly spaced. And the issue comes about if I go here and go align. So firstly, I'll align all their centers together, which should be fine. Yep, that's pretty much all the centers, and they've come into a nice line there. I might drag that so it ends up there. The second thing I want is the space between each one to be even. Now if I do this align distribute here, take off the align because they've already been aligned to centered, and this time I want to distribute their center points just to show you what happens. And you can see that the spacing between this one and this one and this one and this one is not equal to the big space in here nor the big space in here, because what it's done is it's actually distributed these, and I can give you a little example here using our duplicate command, move and duplicate command. 1, 2, 3, 4, 6. I want to retain the original from center to center. So you can see what it's done is actually put these center points in and it's aligned all the centers of these objects to those. Whereas what I'd ideally like is the space to be even between them. So I'm just going to go back here in time to when I had them slightly offset. And I'm going to this time align distribute with the spacing command. And you should see what it's done is made the gap between each one of these, just as a representation here. It's made the gap between each one of these the same size. Let's see if I can lock to there, lock to there. There you go. So that's the align distribute command. It's very handy for if you're doing large patterns or if you're doing multiple items, say distributing a whole heap of things across a stage. You all want them to line up to the front line. If you're doing lighting designs as well, getting things onto bars can sometimes be tricky. The last option here is the scale objects command. And this is really handy if you're scaling up or scaling down an object. If you've imported an object such as a leaf and you want to upscale it 100 times so it's the size of, a boat or something like that, this can be really handy. So I'm going to select my random polyline object at the moment, polygon if I made it whole, and I'm going to use the scale object command here to make it smaller at first and then larger. So I want it to actually be smaller. A scale factor upwards in these numbers here in X, Y and Z is the same as multiplication. So timesing this by 5, it will grow 5 times larger. Similarly, if I want to type in 0.5, so timesing that number by 0.5 will make it half the size that it is at the moment. If I click OK, you can see it's now half the size. There are a few other options here under the scale objects command, and they're just kind of to help you with figuring out what scale things need to be. So if you're measuring on a plan and you know that the current distance of an object that you have is what have we got here, 1000, so let's say it's 1000 here on the page, but in the real world it needs to be 3150. You can type those in there and know that when this scales up it's going to be exactly the right size that you need it to be. So moving right along, we're going to talk about adding, subtracting and intersecting, and no doubt for you guys that have done the class last year, you will be quite familiar with these techniques, but just to run you through them again and just get you back up to speed, we'll do a couple of little exercises in it. So I'm just going to demonstrate the principle here, the 3 principles of adding, subtracting and intersecting. I'm just going to draw 3 boxes just completely arbitrarily here. There we go. And I'm also going to draw 3 circles. Lovely. And they're really easy things. It's just mastering which ones to use at the right times and knowing whether which objects you should be using as your base object. So I'm going to start with adding now as my first one, and I'm just going to put this circle here and say these 2 objects here, that's how I'd like them to be. I would like to add them now and create one surface out of the 2. Obviously last lesson we were grouping things together and making them look the same, which is fine in some cases, but eventually there's a point where you need them to be one object and not have this line and being able to pick them up and all that kind of stuff. So what I'm going to do is select over both of them here, and you can see I've got 2 objects selected. Now there's 2 ways to get to the addition section of the menu. You can either right click on the objects you have and go down here to add surface. Or secondly, you can drop down the modify menu, and about midway down here you'll find add surface as well. Clicking on that and you can see it's created one surface out of these, and it's also redefined it as a polyline. It's no longer made up of basic shapes, it's a complex shape. So yeah, that's pretty straightforward, and hopefully most of you are all over that at the moment. And its secondary partner here, I'm going to do the same thing, put a circle into there. Now this time, and this is what we used to call the cookie cutter if you remember last class, after you've selected both objects and you go right click here, you can get to clip surface, is the 2D name for it, otherwise it's here as clip surface. And clicking on that, it doesn't appear to do anything, but what it's actually done is taken whichever object was on top and sliced through into the object underneath. Now what's really good about this is that you can do multiple objects at once. So say for example I'm drawing a triangle. If I make this object here, then I'll just grab this, cover up this section, grab my mirror tool on mirror and duplicate, mirror that down through here. So now I've got two objects on top of another object. And what I'm going to do is select over both of those, and using a drop down here again, I'm going to clip surface. And what it will do is give me the exact same result, but you can see when I delete these two that I'm left with a triangle because both of those objects on top have sliced through to the object underneath. Now just remember, if you do have multiple objects on top of each other, that whichever one is on top will actually slice through multiple objects in that sequence there. So in this case here, I expect this triangle underneath to get sliced by the two objects on top, and I expect this rectangle to get sliced through by the object on top of it. Let's just make sure that happens. You can see here if I delete this object, it's eliminated everything underneath it. If I delete this object, it's eliminated everything underneath it as well. So just remember that when you are using that command. The last one's the intersect command, and just to show this off best, I'm going to put this circle here. And what the intersect command does is essentially the overlapping parts of any shape it will keep or create a new object, depending on which version you're in. In 2012 it will create a new object from the overlapping parts of any of your current objects. So the overlapping part here, and you can see it highlighted in this light orange, is this quarter of a circle. So if I drop down from the menu here and go intersect surface, or if I right click once again, I can get it from here, and you can see what's done is created a new object from the intersection of these two objects. If you are doing it once again with multiple objects, it will just give you multiple intersections, and you can keep doing that endlessly, obviously. So there you go. So that's adding, subtracting and intersecting. Just a little thing to remember, that subtracting is called clip in the 2D version. It is actually called subtract in the 3D version, which we will get to in a moment. But hopefully that's your basics down, and once you've done that you should be able to complete the exercises that follow. For your first challenge this lesson, see how many of these tools you can create in 2D using the techniques you know thus far. Try to only spend about 15 minutes on this project. Good luck. So we've spent a lot of time learning about the 2D elements of Vectorworks, but eventually you'll want to start moving into the 3D realm. To achieve this, everything that's now drawn in Vectorworks 2012 is automatically drawn on the 3D plane. So if you see here, I've drawn a rectangle, and I'm also going to copy that rectangle and extrude it. Now I do this with Control E. You guys would do it with your Apple key E, or you can do it here from the model menu under extrude. Once you've clicked on extrude, it will ask you mainly for one thing: what is the extrusion height? In this case I'm going to choose 300. Now what you'll notice is not only the 2D object here, known as a rectangle, but also this 3D object here, a rectangular prism, are both drawn on the 3D plane, and the moment that I go to the flyover tool and start flying around the plane, you'll see that both objects are drawn on the 3D surface. This also is the first opportunity for us to have a look at the Z-axis indicated here in blue, which indicates the height of an object. We still have our green Y-axis and our red X-axis. The first thing you'll want to do when using the 3D realm is to learn how to effectively navigate around it. I'm using the flyover tool at the moment, and the flyover tool is really handy. It comes in several different modes here. The first mode that you'll normally find it on is the interactive origin mode. And what happens with that is that any location that you click, for example this endpoint here, will be set as the primary focus of the drawing. So you can see now that when I rotate around this object, it's focused on that corner. If I then want to change and perhaps move to this corner, I simply click once and then click and drag to move around again. It'll take a while for you to get really adept at moving around a 3D object. Occasionally people will find themselves flipping over the object several times before figuring it out. The other best way to move around an object is to use the view panel up here. At the moment you can see I'm in a custom view. By default we'll be in a top plan view which has the full grid layout. Pressing 0 will take you to top plan. Pressing 5 will take you to top view. And then working your way around from top are all of the basic views. So for example 2 is the front, 8 is the back, 4 is the left, and 6 is the right. And then there's some isometric views. 1 being left isometric, 3 being right isometric, 7 being left rear isometric, and 9 being the right rear isometric. So you can see here that I can easily jump around these objects just by tapping the num keys. So I'm just going to spend a moment drawing a few objects in the 3D space and moving them around for you. As you just saw, you can draw any 2D shape. Here I'm going to draw another box and just run over the extrude command again with Ctrl E and give it a height. In this case I'm going to choose 100. This can work with any object though, a circle or perhaps a custom polyline. So these shapes, no matter what they are, when they're extruded, will still function on the plane. You can see here, I'll do this one as well. I now should have a series of objects, all extruded on the plane. Moving these objects is sometimes troublesome, especially when working in custom views. For example here, if I try to move this object over to here, I have no idea where laterally in space that could have moved to. Sometimes snap points will still work. In this case here you can see that I've snapped on top of the other box. This might work to your advantage, but it might also not work to your advantage depending on if you're trying to access a different point. For example, if I try and grab this and place it on this bottom corner, it's very hard to distinguish which point this actually is. A better way to move things in 3D is to choose one of your views and then move it. So for example, I'm in a left view at the moment. If I wanted to line this up at the top of the highest box, I could lock to the endpoint in the left view. Then it would be a matter of switching to another view, perhaps a back view, to align it to a different point. Multiple moving stages are often better for moving larger objects. With 2011 and 2012 comes the introduction of the Pushpull tool, which is a really handy tool, and I'm glad the Vectorworks have finally cottoned on something along the SketchUp lines. I'm just drawing a few more basic shapes here, and then I'll get on with it. So I'm going to jump into a right isometric here and select the Push-Pull tool from the toolset. If your toolset isn't showing, feel free to go to the window, Palettes, and click on Toolset underneath the basic toolset. Once you've clicked on the 3D option, which is here, select the Push-Pull tool. What the Push-Pull tool enables you to do is select any object or surface, and then after clicking on it once, raise it up to a desired height. You can press Tab and type in a height if you desire. Now this is really good for making quick changes to objects because any surface can be selected. You can see I'm highlighting some here in red, so if I instead want to drag this out, then make it slightly larger, or shrink this object back down again, that can also be done. Although you'll be able to create most shapes from basic 2D objects and then extruding, there are some shapes that cannot be created simply from 2D objects. The sphere is a good example here from the toolset. You can see here by clicking once and then choosing a radius, I can create a sphere. The Vectorworks sphere, although great, cannot be edited or cut into in any way, shape or form, due to the way that Vectorworks draws this from a formula. There are a few others here, such as the cone and the hemisphere. Once again, the cone and both of the spherical objects cannot be cut into by any other shapes. When working in 3D, a lot of the old 2D principles are still valid. For example, if I go back here and create a few custom objects, a lot of the same principles still apply. I'm going to select a few of these and extrude them to different heights. And then use some of my basic principles to do some different things with them. In this case, I would like to cut this circular hole into this square block. By selecting both of the objects and either right-clicking or choosing from the model menu, subtract solids. This is a very similar process to clip surface, it's just one menu over. You'll find this little dialog box appears, and the main purpose of this is to choose which objects is being cut into, as in the 3D realm there is no on-top object. Just scrolling through with the arrows, you can select the object highlighted in red. In this case I want to cut into the box, and click OK. You can now see that I have cut into the box a circular hole, even greater, shown by the rendered modes. Conversely, had I wanted to add these two objects together, I could simply line them up, select the two, right click and choose Add Solids. Now these will operate as one and be picked up as one. Just to reiterate our 2D and 3D skills, I'm going to show here you can also use intersection. Obviously that is the central element that was common to both of those pieces. Once you're familiar with creating objects in the 3D space, you're no doubt wanting to move them, rotate them, mirror them, or some of the other functions that are available. I'm just going to run through quickly a few of those. Once again, I'm going to create some basic 3D objects. And extrude all of them. There we go. In the previous lesson we learnt about the move command, and the move command still works here, there's just two different variations on it. And I'm going to do this from the isometric view just to emphasize what I'm trying to say. Here I've got this box, and I'm going to make a copy of this box and keep it in the temporary memory. And then I'm going to go from the modifier menu with the box selected, move, and move 3D. Now it doesn't matter if you're on the Cartesian plane or the working plane in this example. Should you choose to one day move your working plane, the Cartesian plane is your default Vectorworks plane and the working plane is wherever you've moved it to. For now I'm going to work with the Cartesian plane because our working plane and Cartesian plane are the same. I'm going to move this box down by 100 in the Z axis, so it should move down along this blue line by 100 according to the plane. There we go. I'll move it around so you can see it in a second. I'm going to paste in place now the original box. And then I'm going to also move it here with the old move command. here I'm going to offset it in the y-axis, which would normally be up and down for us, by 100. You can see it's also, perspectively, looks like it's gone down 100. What you will notice though, when I move to a front view, is that they're actually offset. The reason for this is that this box here has moved directly down. This was our Move 3D box in accordance to the plane. This box here though has moved respective to where we were looking. It has physically moved down in the direction that we were looking at the time that we moved it. So naturally it's moved slightly diagonally down. It's something to remember that when you're in front view, or any of the basic front-on views, the two operations will seem the same. But when you're in an isometric view, moving objects is often very complex. I'll also quickly show you an example of rotating. Rotating in most of these will operate exactly the same as normal. What I mean by that is by clicking at a point and then drawing an extension line out in any direction you choose, and then rotating will operate on the base plane. As you can see here, although I'm floating in an unknown space, my object is still moving around the plane in a normal motion. From a top view, this would still appear to be like this. When in an isometric view, they've made it very difficult for you to muck up rotating around the plane. There is actually no way at the moment that I could grab this object and take it off the plane in an isometric view. In the side view, you'll notice that Vectorworks automatically chooses the plane appropriate for the rotation. Here I've drawn my pinpoint down here, an extension line along this axis, and you can see now that I'm rotating the object in the plane that's flat to us. Now from above, this object looks as you'd expect it to. And just to emphasize that point here, this object here, which is flat in a side view, choosing the point, extension line, rotation, now looks like this from above, and this in front. Mirroring is much the same. Draw an extension line, mirror across, draw an extension line, mirror across. As you can see here though, the mirror actually creates its own plane when you use the tool. So here, if I draw on an odd angle, the object will flip at the odd angle. There are several other options here, such as Rotate 3D and Align and Distribute 3D. Although I won't show them to you now, feel free to explore them under the Modify menu later on. Hopefully now you're ready to start our first exercise for this section.
Lego is here. Hey, kids, look! A whole new world to build. 'Cause Lego is here.
This young boy has such fun. He used Lego one by one. Wibbly, snap, paddywhack, doing double plane. This young boy glad Lego came.
Lego, a whole new world to build.
This young girl has such fun. She used Lego one by one. Wibbly, snap, paddywhack, built a house of grand. This young girl's a Lego fan.
Build hotels, animals, people, boats, skyscrapers, and more. So kids, get your Lego set now at department and toy stores everywhere. Lego, the sensation of Europe, now made in America by Samsonite, who make it better for longer lasting fun.
The remainder of this portion of the lesson is conducted in class. If you are not currently in class, feel free to move on to lesson 2B.